So dictionaries and sets. So what is this? Um, Let me tell it in this way. In a list, we have items, and for each item we have an index. What is an index? It's a numerical value. I know that it always starts from 0, and it goes up to the number of items minus 1. So if I have 5 items, the last index is 4. But always the first item is 0, and it always increments by 1. Now Python has a very interesting, and doesn't exist in many other languages, that they said, okay, index should not be only a number. It can be also a string. So then we will call them dictionaries. And what is a dictionary? You can think of it as a list in which these indexes are not numbers, but they are strings. But it has a many different implications that we will see now. So in an index, I know that it starts from 0. And let me first give an example why this might be useful. Well, let's say that I want to keep a phone book in which I have people name and their phone number. So if I had kept it in a list, well, I could do it. I could create tuples like, I know, Ali's phone number, and then Mujahid phone number, whatever. I can keep those kind of pairs, and then I can put them in a list. But then I'll ask, okay, what was the phone number of Mujahid? How could I find it in a list? I have to iterate over all the items in that list and check, okay, whose name is Mujahid. Once I find it, okay, now I found it, then I can get the list, get the phone number. But I have to do this process all the time. Instead, but if I had put it in a dictionary, what I would be able to say is that, okay, I want to get the phone number of Mujahid or Chris, as in this example. I would just say, my phone book, between square brackets, instead of putting a number, this part is important, I just put the name itself, like the Chris, and then it will give me the value that I'm looking for. So this is the best advantage of it. Now the index does not have to be number, it can be also strings. So when we are defining a dictionary, like a real dictionary. In a real dictionary, the index is not numbers. It's in a dictionary we have words and their definitions. So the word and definition, all of them is defined in this way. So we also have this. We will have keys, indexes that we use, and their corresponding values. So in a dictionary, it's the word and the meaning. In a phone book, person's name and their phone number. So we can say it in this way. So I need to define it. But here's one challenge again. Now, what is in a normal list that we use numbers, I know that the smallest number is 0. So I can start from 0. But if it is strings, what should be the index of the first one? Where should I start? So this is where I also need to define it. Like when I'm defining a dictionary, I need to say that, okay, Chris is my key. It's the index of it. And its value is this one. This is his phone number. Katie, and this is her phone number. Joanna, and then this is her phone number. So I need to define key value pairs, or string index and their value representations. Let's do one example. Let's say that we have this. Let's say that I would like to keep the grades of students, okay, in a dictionary. So again, one big difference. I will not use square brackets. I will use curly brackets. When I do this curly brackets, now this becomes a dictionary. Now this is an empty dictionary. Now I would like to put it like I want to keep the students' grades. So as an index, I will use their name. I could also use their QID number, whatever you think that's suitable, for instance, and then their corresponding score. Aisha is 4, Fatima is 3.5, I don't know, and Ali is 3, and so on. So now I define my dictionary. So what I can do is, okay, I would like to say, okay, what is the grade of Fatima? I don't remember that. So now again, might be confusing. When I'm trying to access the data, I will use curly brackets. When I'm defining a dictionary, I will use, sorry, when I'm trying to access a dictionary, I will use square brackets. When I'm trying to define it, I'm using curly brackets. So there's a difference. But I would like to get, okay, what is the grade of Fatima? Then I will just say grades between curly brackets and then Fatima, and then it will give me 3.5. This is her grade that I kept. Okay, so this is the main feature of dictionary. If you understood that what is a list and what is a dictionary, in a dictionary we have string indexes. You got 90% of what a dictionary is. The others are just detail or other implications. Now, here's one challenge. Again, if I know that I have 5 items in a list and the indexes are numbers, I know that there's some item in the index 3, there's some item in index 4. I don't need to worry about it, as long as I know how many items are there in the list. But in a dictionary, now, okay, I know that there are 3 items, there are 3 students, but what are they? I cannot use 0, 1, 2. What is their key? If I don't know it, well, that will be problematic because, okay, I know that Fatima is there, that's why I got it. But if I had asked, okay, what is the grade of Reem? I'll get an error because Reem doesn't exist. But then, again, if you have no idea what the students' names in that class, you'll be in a big problem. So what we need to do is, like, whenever we are using this function, this dictionary to check for, we have to use this first in operator. Like, is this Reem in this grades? Then we can print her score. Else not. Else we can. I forgot to put this print operation. Sorry. Then I can say print Reem. Otherwise, I would just say print not found. So this in operator, we use it a lot with the dictionaries. The reason is that we don't know where the index starts. What is the smallest string? We don't have this kind of information. Where does it end? We don't know. So therefore, when we want to process it, we use this, is that in this grades or not? If that, we will use it. Otherwise, again, we will get this key error problem. And do you have any questions so far? By the way, this, I mean, if you understood this part, you got 90% of the dictionary. That's the main. The other parts will be just a little more details, but 90% is this part. And in a dictionary now, in a list, we would use append to add some item because we have a starting and an index part. Or we could insert to put a data in a given index. But here again, we don't have it. We don't have this numerical part. Then how can I add a new value? I think I will, if it's not that, I will immediately upload it after the class, okay? What was I saying? How can I add a new value? Well, actually, it's pretty easy. I don't need append function. I don't need insert function. I can easily say, like, okay, Reem doesn't exist, but I would like to add the scores for Reem, okay? So what I can do is, I would just say Reem and her score is 3.7, okay? Then I will have Reem in my list. So if that key doesn't exist, it will add it. But you might say, okay, what if it exists? Like, I said that Reem is this part, but okay, what about Aisha? If I say Aisha to do this, and it exists in the list, now what will happen is, when I do it, it will just update it. And now when I rerun, check it, now, as you can see now, Aisha is 3.7. Here, it was actually, previously it was 4. So update it so easily. If the data exists, it updates. If it doesn't exist, it just adds it to the list. And again, how can we delete it? Like very similar to what we do with the list, we can use this del function, and then basically then we can call with our dictionary name and then with the key. So I would like to delete Chris from this phone book. Then I just need to use this del function. In the list, we were putting their numerical value, numerical index, but here we have strings so that we can use it. But again, if it doesn't exist, well, then key error will be raised. Any questions so far? And again, how can I know how many items are there? Well, same with the list. We can use this len function to get the number of items in a list. And keys must be immutable objects, but the other ones can be immutable, which means that you should not be able to change it. This is important because we are using it as an index. So we are using this, for instance, strings are immutable. That's why we are using it. But it doesn't have to be only string. It can be actually other immutable objects. That would be also correct. For instance, as a key, here I used a Boolean variable. I just said true 5. Okay? So then, so I can say true 5, false is 3, 4. So I'm using here the Boolean variables as a key also. So in Python, it's so flexible. Like the index doesn't have to be number. It can be strings. It can be Booleans. It can be any immutable. Immutable means that you cannot change its value. You can use any immutable value as an index. So this is a huge flexibility it brings up. But in many cases, we just use strings because in most of the cases, we just use strings as a key. Any questions so far? All right. Here's just as another example, which we keep not a phone book, but for the people and their birthday. So just one more similar example in which we can ask user to, what do you want to, we are assuming that the user has a birthdays dictionary. And then we just define functions to look up it, how to add an item, how to change an item. We all have seen it, so I will just skip it. But of course, when you are studying it, you can definitely go and check these parts. Let's say that let's look at one example. Let's say this example. For a change function, I would like to change this birthdays. This is a dictionary. We ask user to provide the name that you want to change. And then we check, okay, is that name, is it in our dictionary? If so, we ask, okay, what is the birthday that you want to change? What is the new value? We get it from the user. And then we just change in this way. For the birthdays, this is the index that we use for the name. And okay, this should be the same, the new birthday. Like in my code, I had used it here, like how we change it. Similar, just another example for changing a value in a list. Any questions so far? All right, then let me proceed. So I can add more items in a dictionary. So what we can do is, we can first create an empty dictionary, and then we can just fill it. So what we can do is, how to create an empty dictionary? We can first either define it by open a curly brackets, and then immediately close it. Then it will give us an empty dictionary. Or Python has this dict function, stands for dictionary. If you use it, you can use it to create a new empty dictionary, so that it will, so basically the same function for us, that we can use it to create a dictionary. Then the next part is, okay, I filled it. How will I proceed? Like, if I don't know any idea, if I have no idea about the dictionary, like the keys, okay, I just know that, okay, this is a grade dictionary, it keeps the grades of the students, okay, but I have no idea who are they. Like, should I say, okay, is Aisha there, is Reem there, is Fatima there, is he, so I cannot do it, because again the index is string and I don't know where it starts, where it ends. Then how can I iterate over the all items if I don't know the keys? So for that one, basically we can use a for loop to iterate over that. So in a for loop, it gives us the keys. Like in our example, for instance, for our grades, uh, since, since we keep names as a keys, I will say name. For name in grades, then it will give me the keys in my list, in my dictionary, and then I can use that key to access their values. So when I do it, it should be grades, sorry. This should be grades, yeah. So by using a for loop, I iterate over the keys. My keys are the student names, Aisha, Fatima, Ali, Reem. So I iterate over that. So that's why I printed the key that I got. And by using that key, I can also access the value that is associated with that. So Aisha and her grade, Fatima and her grade. So I can iterate over a dictionary, even though I have no idea what are the keys in that list. Any questions so far? All right. And Python provides even some more functions for us. Like if you use clear function, it will remove all the items, all the key value pairs from the dictionary. So it will be again an empty dictionary. And this get method is important. Well, why? Well, I know, okay, this is my dictionary, grades. And then let's say that I try to reach the score of Mujahid, okay? But, okay, it's not there, so my program failed. Well, I don't want this to happen because my code was running and then it just fails. It stops execution. This is like very uncanny case. I don't want this to happen. So either I will check, okay, is Mujahid there or not? But again, will I every time when I do it, should I check if he is there, if he is there? So that would unnecessarily complicate my code because every time it checks and then I need to use an if statement. I don't want it. So what I can do also is by using this get function, okay, I would like to get the score for the Mujahid, okay? But if it doesn't exist, if the score, then just say that, okay, the student is not in the class. So if it doesn't exist, it returns me the value that I provided. Okay, if it doesn't exist, please say to me that the student is not in the class. Please don't crash, but just give me that string. But if the student exists, if it is there, like if you would like to get the Aisha, okay, then we will get the score because she's in the list, so we get the score. So no need to say that the student is not in the class. So this get function is for our program not to fail, even though the data that we are trying to reach is not there. Any questions so far? All right, the other one is items. So I would like to process the data again, iterate over the data. One way was in our example, as we had seen previously here, I can go over the keys and then use it. Another way to do it is I can say items, okay? It will return me like a list of tuples, and each tuple is a list of pairs, and each of them will contain the keys and the values. So I will have two values here. For my case, name and the grade, okay? Then when I'm trying to operate this, now I don't need to access this values, this score of the students by using this name key, I can just say grade, and then it will give me exactly the same score. So this code, and also, oops, sorry. Does exactly the same thing. One of them gives me only the keys. The other one gives me key value pairs. In one of them, I can use that key to get the value. The other one already provides me that value. So both are, you can use any of those if you need it. And the other part is, there's also another function called keys. Well, keys only returns, this is very equal to this one. Again, this keys function returns only the keys that is in the list. So so these are basically very same, but let's look at what this shows. So this is keys, this is items that we have seen so far. So check that you're giving us those pairs. And there's one more part, which is values. So in this part, it doesn't give me the keys, but it just gives me the scores of the students. So based on your need, like if you just need the keys, then just call this one not to process the others. If you just need the values, maybe I just need to find the average score, then I don't need the student names. I just need the values. So I can use this values function. But if you need both, then you can use this to get the both values. Any questions so far? All right, I had already talked about these keys. Another one is this pop method. So now pop is a term that we use for actually a very specific data structure that we didn't see in this course. But what pop means is it removes one of the items from the list, and it returns it. So for my dictionary item, if I use this pop with a given key, if it exists, it will remove that from that list, and if it doesn't exist, it will give me this default value. So let's apply it in our own program. So let's say I would like to get Aisha's score, and then I would like to remove her record from my dictionary. That's why I will use this pop function, okay, in which I will give the key that I would like to remove, and if she's not in that list, I will give, for instance, -1 or 0, whatever, if that student does not exist. So when I run this code, then what happens is now, what is Aisha? Well, it is 3.7, as we had done it before. And okay, what happened to the grades? Now, what do we have in the grades? Well, we have Fatima, Ali, Reem, but we don't have Aisha anymore. Her record has been removed. So we can use this pop function to do this. And the other one is pop item. Well, it has a different meaning. Oh, sorry, let me do it in this way. Pop item removes the last added item. So I have a dictionary. I keep adding items. I added Aisha, I added Reem, I added Fatima, I added Ali. Then, okay, no, I have to remove Ali. So I have to remove the last item that I added. So then what I can do is I can just use this pop item so that it will be removed. In our case again, oh, I have 10 minutes and 14 slides. I need to be a little bit quick. So I think Reem was added last. So when we say grades pop item, it returns me Reem, and it doesn't exist anymore. So it removes the last added item. We have already seen the values method. I had given the example, so I'm skipping that. And these are the functions that we have seen. So again, we have seen all these items. Do you have any question about the dictionaries? Now we will start another one, a set function. All right. So we have seen list, we have seen dictionary. In a list, the index is numbers. In a dictionary, we have still some ordered data, but the index is some non-numerical value it can be. What is a set? Well, it's the mathematical set. In a set, remember those Venn diagrams that you draw in the math class. So similarly, in a set, the objects are not ordered, like in a Venn diagram. Or you might think it like a bag. In a bag, you put all your items, like a grocery bag. Okay, then you might say, okay, what is the first item? Well, we don't know. It's unordered. So in a set, we don't have this index. It's just a set. It's unordered. But one unique feature they have is that all items will be unique. So this is interesting part. In a list, I can add one and then add this value of 1 again and again and again. I can add the same value multiple times. But in a set, it won't happen. Like if you keep adding 1, it won't keep multiple 1 value. It will keep only 1. It will keep each value only once, not more than 1. So this is the main feature of sets. If you notice, again, this is like maybe 50% of what a set is. And then, well, how can I create a set? Well, I can create a set by using set function, or I can create, if I give a list or a string or a tuple, it converts it to a list. I would like to give you an example for this one. Let's say that I have this list. I would like to create a list first, in which I will have these 1 or 2, 5, and then I will have multiple ones in it, and maybe some more 2s. There's a 12 I put. Anyway, let's say that this is our list, okay? Then I would like to convert it to a set. How can I do it? By using the set function, and then I will give a as a parameter. When I do it, now what happens is, exists in set B? Only the unique items in A. In A, I have 1, 2, 3, 4, and there's this 12. So that's why, here is the 12 that we have. That's why it removes all the duplicates. It keeps only 1 copy of each item. This is the main feature of set. Again, once you know it, the rest is just some detail. Like the data is unordered, and it keeps on the unique items. And well, how can I know how many items in a set? Again, same function, len function, returns the number of items in a set. How can I add a new item to a set? Well, I will not append it. Append suggested we put it at the end, but the data is unordered. So that's why we just add it. We can use this add function. And also, we can update to as a group of elements in a set. And how can we remove an item? Well, I don't have an index. I have only values. This is the part. So in order to remove it, I just remove the specified item from the list. Okay, remove this one, and I can use 2 different functions. One of them is remove, and the other one is discard. What is the difference? Remove, if the item doesn't exist, like I have items A, B, C, and I want to remove D. Well, then I will get a key error if I use the remove function. But if I use the discard function, it won't raise any exception. But again, in a set we cannot use del function, because we don't have index in a set function. We just don't have it. So that's why there's no del function. We have discard or remove, and clear as what it does with the strings and with the lists and dictionaries. It removes all items in a set. And again, how can I iterate over an item in a set? Again, the core knowledge that you have to memorize is the rest you can just identify it. There is no index. Then how can I get okay, give me the 3rd item, give me the 5th item? I cannot do it. There is no index. The only way I can go over that is by using a for iteration. Using a for loop, I can iterate over them. Even though I don't have an index, I can get the values, and then I can process it. And again, I can use this in operator. This is important to check if the item is there or not, because if I don't know, I have a bag full of items in that, like a grocer bag, and I don't know what it is there. So I need to use this in operator to check, okay, is that here, is that, did you buy banana, is there banana in it, is there any apple in it? So I can use this in operator to to check that. And well, I have 5 minutes, but I will be able to finish it. The rest is pretty similar. Do you remember mathematical SAT operations in mathematics? Like, we have these Venn diagrams, and then we just define this exactly the same concept, the SATs in mathematics. This base structure also allows all these SAT operators. Python, what is that? Well, you have these two sets, set 1 and set 2. I want to take union of them. Then how can I do it? Well, I can use this union function, set1.union set2. It gives me a union of that set. What is a union of two sets? If I have ABC in one part and DEF in another set, what is the union of these two? Have you ever seen it in mathematics? You didn't? Alright, well, the mathematical concept is not covered in this class, no worries then, but at least know that how to take the union, what is it, okay? And then I will not have time to explain it, but short story, if it is ABC, and then I have CDE, the union of them is ABCDE, so all the items in that one, it will give me the union. So to take the union, I need to use this union function, or I can use this bar operator for the same operator. And for the intersection, I can use this intersection function, or I can use this AND operator. What is an intersection? ABC and CDE. What is the common point? C. So intersection of these two sets is C. So it gives me this, I can use this intersection by this. And what about the difference? So I have ABC, one list, and CDE in another list. If I remove ABC from CDE, if I remove CDE from ABC, so what will happen is C is common point, so I will remove C, so I will have AB. So I can do this take difference operator by using difference option, or I can use this operator. So it will basically remove all items in set 2 that also exist in set 1, and then we'll keep the remaining items of set 1. This is the difference. So what makes set 1 different than set 2? This will be the output. And what about the symmetric difference? It is, again, I have these two sets. So what I will do is, okay, what are the items in set 1 that doesn't exist in set 2? So I will put that one in one side. And then what are the items that exist in set 2 but not in set 1? Then I will put it also in that side, and then I will merge them. This is the symmetric difference. So I can use it by using symmetric difference function, or I can use it with this operator. And the other part is subset. So is set A subset of B? What does it mean? If all items in B exist in A, then it means that B is a subset of A. So but of course, when we say that is subset B, which means that is A subset of B. So if does all items A exist in B? If it is, it means that A is a subset of B. So this will return me true score. Otherwise, it will return me false. Or I can use this comparison operator. And the last set operation that we will see is supersets. So what does it mean? Is A superset of B, which means that does all the items of B exist in A? If it is the case, which means that A is the larger, or at least the larger, or at least the same, but it contains all the elements of B, so it is a superset of B. So that's why if it is the case, then it returns me true, otherwise false. So in short, I will stop here. In short, we can do all mathematical set operations by using this function. Python supports all these functions for that one. And it's 10:50. I think, yeah, I should stop here. I will take the attendance in 1 minute. So please log in your Blackboard.